Hi, welcome back. I'm Rakesh Naik. Today we are going to discuss about Introduction to Design and Analysis of Algorithm. But before we start, this small information I'd like to say. We produce every video in two different languages, Hindi as well as in English. If you want to watch it in Hindi, kindly follow the link given in the description. And if you have not yet subscribed, kindly subscribe and press the bell icon so that you will get all the updates from this channel. So let us start the introduction of design and analysis of algorithm. This is a very important topic from every exam point of view. In this topic, we learn whether we should design and analyze any algorithm or not. In GATE, in PSUs, in any exam you take, you will get a question from design and analysis of algorithm. So it is a very important topic. Algorithm is defined as a finite collection of unambiguous instruction occurred in some specific sequence, and it should produce an output on zero or some input in a finite amount of time. So in very simplified format, if I want to say an algorithm must take either zero or more number of inputs, it must produce at least one output. Each instruction must be clear and unambiguous, and it must terminate after a finite number of steps. So every algorithm to execute, you need to give some kind of input. The input may be 0 or 1 or 2, any number. And ultimately, it must produce an output. And the instruction that you are giving, it must not be confusing at all. And after 5 step, after 10 step, 15 step, after a 1 hour of time, after 1 year of time, but you must be in a position to say the program or the algorithm will stop after certain time. So these are the basic characteristics of any algorithm. If we are having a problem to be solved, then we write the algorithm first to solve that particular problem. And based on that particular algorithm, we write a program based on a programming language. And this programming language and the input that we'll be giving to produce the output. So this is how a problem basically is solved. And right now we are focusing here at the second step, algorithms. So whenever we are talking about algorithms, there are 5 distinct areas of study in any algorithm. To devise an algorithm, to express an algorithm, to validate an algorithm, to analyze an algorithm, and to test a program. When we are saying we are devising an algorithm, it means this activity where some human intelligence is definitely required. And some of the strategy used have a general capability like dynamic programming, divide and conquer, backtracking. These are some devices, or these are some ways to put the things into steps to get the solution of a particular problem. Next one is to express an algorithm. An algorithm can be expressed in various ways, like we can use a flow chart, we can use a pseudocode, we can use a program-like structure, we can use English-like structure. And there are different ways by which the algorithm can be expressed. Casual or naive programming, structured programming, object-oriented programming, use of recursion, and there are many more. And the next thing is to validate an algorithm. This means the program satisfies its specific specifications. This involves proving the correctness of the algorithm. Once an algorithm is shown to be correct, only after that the coding is supposed to be done. And the program also to be verified by testing, profiling, and other techniques. The next thing that we're supposed to do is to analyze an algorithm. This field of study is called analysis of algorithm. It concerns with the amount of time and storage that it requires by an algorithm. This study allows us to compare valid algorithm for efficiency. Next thing is about testing. The testing part is consist of two things. One is debugging and another is profiling. It is important to be familiar with debugging of a program. Basically, debugging can only point to the presence of an error and never their absence. And profiling is the process of executing a correctly working program with the appropriate data set and measure the time and memory space it takes to execute various parts of the program. Now let us try to discuss what are the steps that we generally follow to design an algorithm. So the basic steps are understanding the problem, decision making. The decision making can be on the data structure, the algorithm strategy, choice of exact or approximate method, capability of computational devices, then specification of the algorithm, algorithm verification, analysis of the algorithm, and implementation algorithm. Let us try to discuss this one after another. Understanding of the problem. This is the very first step in designing an algorithm. In this step, first of all, you need to understand the problem statement completely. While understanding the problem statement, read the problem description carefully and ask questions for clarifying doubts about the problem. But there were some types of problems that are commonly occurring, and to solve such kind of problem, there are typical algorithms which is already available. Hence, if the given problem is a common type of problem, then already existing algorithm acts as a solution to the problem. And after applying such type of existing algorithm, it is necessary to find the strength and the weaknesses. But it is very rare to give such a ready-made algorithm. Normally, you have to design your algorithm on your own. Until now, there is no automation done for developing of an algorithm. In order to understand the particular problem, you need to understand the range of inputs that you are giving, which are the valid inputs that you are giving, what are the approach to solve the problem that you need to decide. So these are the few things that you need to understand before you start writing an algorithm. The second thing is about data structure. Data structure and algorithm works together, and these are interdependent. Hence, choice of a proper data structure is required before designing the actual algorithm. The implementation of the algorithm or the program is possible with the help of algorithm and the data structure. Next thing that we need to decide is about the strategy. How you are going to approach the problem in order to solve it. These problems may belong to different areas of computing. Algorithm strategies are also called as algorithmic technique or algorithm paradigm. So in that we are having brute force method, divide and conquer, dynamic programming, greedy method or greedy technique, backtracking, and there are many more. So we need to decide which strategy, which algorithmic strategy we need to adopt in order to solve the problem. The next thing is to decide the exact or approximate method. So a method is required to solve a particular problem, but the method can be either exact method or approximate method. So we need to decide before writing any algorithm. And the next thing is capability of computational device. This is also a very important aspect because globally we can classify the algorithm from the execution point of view as sequential algorithm and parallel algorithm. A sequential algorithm especially runs on a machine on which the instructions are executed one after another. Such machines are called random access machines. So similarly, we need parallel algorithms also where the part of the code can be executed parallelly. So there are certain complex problems which require huge amount of memory, or the problem for which the execution time is an important factor. For solving such kind of problem, it is essential to have a proper choice of computational device, which is space and time efficient. The next step is regarding specification of an algorithm. So when we want to specify an algorithm, it means we want to express the algorithm in the form of natural language, or in the form of pseudocode, or in the form of flowchart. I hope you know about this thing, so I am not elaborating much about this. The next thing is algorithm verification. Algorithmic verification means checking the correctness of the algorithm. After specifying the algorithm, we go for checking its correctness. We normally check whether the algorithm gives correct output in a finite amount of time for a valid set of input. The proof of correctness of an algorithm can be complex sometimes. Some common method of proof correctness of algorithm is by using the mathematical inductions. But to show the algorithm works correctly, we have to show that at least one of the instance of the valid input in the algorithm gives a wrong result. So next step is regarding analysis of the algorithm. In this case, we find efficiency. Efficiency in the form of time, efficiency in the form of space, efficiency in the form of generality, and the range of output. So all these things we talk when we talk about analyzing an algorithm. And the last one is implementation of the algorithm. The implementation of an algorithm is done by suitable programming language. For example, if the algorithm consists of objects and related methods, then it will be better to implement in programming language like C++ or Java, which is object-oriented programming language. While writing a program for a given algorithm, it is essential to write an optimized code, and this will reduce the burden on the compiler. I hope you understood the basic of design and analysis of algorithm. Again reminding, designing and analysis of algorithm is applied every time you write an algorithm. When optimization is important, it is not bound to any specific area. Let us say you are writing a program for medical diagnosis. If you are writing a program, then there is an algorithm behind it. And if there is an algorithm, obviously it must be optimized. It must be correct. It must be validated. So that's why this subject is that important. Thank you for watching this video till the end. Keep watching, keep learning. We'll learn different techniques one by one. So we'll meet in one more video. Till then, take care. Bye.